Okay, recording has started. So welcome to today's tutorial. We'll continue where we left off with our code, right? With the past paper. It's the 2023 paper A. So okay, it's not here, it's under downloads. Then inside here, if I'm not mistaken, 2023 paper A. Mm. Okay, so this is the paper, right? Yeah, with lightning and everything. Yeah. For the ones who recently joined, you have to watch the previous recordings. You have to watch that. Oh, one day I was changing to a record structure. Yeah, we had changed to a record structure. Yeah. Yeah, I remember I'd introduced record structures. Um, let's see. Yeah, I'd introduced record structures. Enums, right? To be honest, with enums, it doesn't make that much of a difference, right? Let's talk about enums. So enums, as you can see here, right? We have all these movements, right? So these movements, instead of declaring them, do you see that we are repeating ourselves a lot? We have constant, we keep on typing constant over and over and over. And it has a certain way, a certain order, meaning it's in incrementing, right? Basically, it's increasing by one, starting from zero. Well, there's this shorter way of doing this. You can do it via what we call an enum, which is basically enum, the word enum, right? Comes from the word in enumeration, meaning to enumerate. Basically, it means to number something, right? So what are we numbering? We are numbering the movements, or we're enumerating the movements. So basically, we are giving the movements numbers, and then we count from some starting point. Basically, numbers. How do we create an enum? You just like a record structure, simply type in the word enum instead of struct. Then after the word enum, you define the name of the enumeration, basically what it represents. In this case, mine represents movement. So I'm going to call it movement. And then you put in curly braces. Then you take all of these constants, right? You put them here because an enum is a way to make it's a shortcut, right? A shorter way to declare constants, especially if they are of the same type. You see that they're of the same type integer. An enum is for integer constants. Keep that in mind.
So what happens if I want to for a double if it's only for an integer?
A double, I think you have to declare them separate. Let me do this because I know Diketsu doesn't mute her mic. So let me mute that for her. Yeah, if with doubles, it's definitely gonna refuse, right? Let's test. Let me prove it to you. Because last time I checked, because I read the textbook, right? They were saying that it's integers. So let me just double check if the textbook was on point. Then you remove all the constant parts because they're added automatically when you create an enum. C++ adds them automatically. And you don't have to initialize to 0 to 1. By default, enums start counting from 0. If you want to change the starting point, you initialize the very first constant to a different number. And then what C++ does, right? Every constant that comes after that constant, it increased by 1. So since we want to maintain the same structure of starting from 0, I don't have to give it a default value. And you separate all constants using a comma, except for the last constant. That's the one you don't, because there's nothing after the last constant. I mean, it's the last constant. So you don't have to put a comma. You put a comma only if there's another constant after that constant. As you can see, the move down to right constant is the last one. There's nothing after, so we don't put a comma there. So let's say you try to do spiritual things, right? You initialize it to 4.0. Let's see what C++ will do. Remember I said you can initialize it a starting point. Yeah, you see, it complains, right? Error. It's strictly for integers and enum. So with doubles, you have to declare them separately. They shouldn't be inside an enum. You see, the value must be an integral. By integral, they mean integer. So it's strictly integer. You're not allowed. As you can see, C++ that disapproves of it. It doesn't allow it. And like I said, you can give it any starting point. So let's say you start at 4. The next one, right, it's basically the previous one plus 1. So it will be 4 plus 1, which gives you 5. And then this one will be the previous one, of which the previous one is a 5. Therefore, this will be 5 plus 1, which is 6. So as you can see, it increments by 1 every time. But since our constants were starting from 0 to begin with, I can just simply remove this. You don't have to explicitly say it's equals to 0 to start from 0. It automatically starts from 0. You only use this syntax if you want to specify a different starting point. Keep that in mind. And I'm going to do this, right? So now we have our constants, right? As you can see, we need to change some things a bit, right? Remember all these moves, they are of, it's like a record structure. They're all of this type in a way, right? In a way, you can specify that it takes in something that we call a movement, which is an integer or an enumeration, which is basically an integer. So everywhere we're passing the movement, you see here, right? It's no longer const int, it becomes of type enum movement. You don't change much if you notice something. We'll still call them or use them inside a CPP file the same way we would implement it without an enum. So let me show you where's the function. And let me zoom out a bit. Okay. Yeah, there's the function. So you see that I can just simply change this to movement, right? And then if I build here, I'll have no errors. Because like I said, the enum is to just make your life easier, to make things short, just like a record structure. It improves your life to shorten things, to group things into one thing. So for example, here we created an enum for movement. And then these are all the constants. By default, C++ appends this const int for you. And it starts at 0, so this will be is equals to 0, which is what we had already, right? But then I don't have to type const int. I don't have to say it's equals to 0. I just only put in the names. I hope that makes sense. And then you can mute. Can you please guys mute? So it takes in that movement, right? Yeah, that's the only thing that changes if you notice. You see, still exactly the same. The only difference is that we don't have to only say const int, blah, blah. We pass in some type, grouped type. Even this one, remember, these are not the only ones. We also have this, which is the game characters, right? And you see that they also start from 0. So we can also enumerate them. So we can say enum followed by what they represent, right? This is going to be kind of hard, right? Why do I say so? They represent my game characters, right? But then I already have something called game character. So I'll just call it game, right? Or symbol. Let me call it a symbol because it represents the symbols that are in my game for an empty space, for operator, and so forth. Then remember what I said, you remove all the const ints because C++ adds them automatically for you. And then remove this, and then remove this, right? And then you don't have to initialize C++ initialize starting from 0. Since they already start from 0, there's no special, any extra things I need to do. And then remember each constant is separated by a comma in an enum except the last one. You don't put a comma because there's no constant after the last one. Since it's the last one, right? Hope that kind of makes sense. And then where is it? Yeah. Remember we need these were our symbols. So now I need to go here. Where is it? No, it's fine. Yeah, it's fine. Yeah, let me build. Let me show you. The code still runs exactly the same way. You see, no error. Like I said, in enum is just a way to save your life and not have to type a lot of things. You can still use them normally like in a constant because they are constants. Look at something here. Code blocks tells you the value. It's inside the min space namespace, inside a symbol enum, and the constant is called empty space and is equals to 0. Even code blocks helps you. You see, if I leave my pointer here, it says it's 1. So I didn't lie. They do increment or increase by 1. It's 2. Operator should be 3. You see, it's 3. So yeah, that's pretty much the whole big fuss about enums. It's not something big. It's just to help you group your enums and don't have to keep on typing constant, constant, constant. But then your code doesn't change. As you can see, nothing changed. I only grouped it into that. The reason why I had to change this other function, right? This one, the function that I think it's the function to move the player, yeah, because it was taking a movement. So that's why I had to change it to the type of the enum since I introduced an enum. But if you notice something, the rest of the code here doesn't change. Nothing changes because they're still constants. So there's nothing too special about it. So we were still doing something here. Update. Let me look at update. Let's do update. I think everything else is fine here. Yeah, I think we did everything. Yeah. Oh yeah, we're not doing main yet. That's why. So we haven't tested it, but I know it should work because I trust my code. So updating, right? The missed operator must be updated as follows. The region of the world within a 1 block radius around the operator must be visible. You see, visible. Hey, this question paper they cooked here, Shem. I like this question paper. It's hard, it's challenging, it makes you think. But then if you know what you're doing, easy stuff. You're like, oh, okay, I create two arrays. One with Boolean, one with that, and so forth. Remember, came up with the formula, right? This formula over here. That if I want to find the square radius, right, I'm gonna need for loops, but then there's gonna be a for loop for rows and then the for loop for columns. As you can see, we say that it's gonna start at exactly that location and stop at exactly this location, inclusive. Same applies for the columns. So, but then before we do that, remember we need to find the operator's location. So current row and current column for the operator. So I'm going to go to my function here and declare two variables. Int current row is equals to 0, comma, current call is equals to 0. Remember that variables of the same type, you can declare them in one line separated by a comma. You don't have to declare them in separate lines. You don't have to waste space like that. Because your code, the more lines you add, the longer your code becomes and the harder it becomes to read. So now we need to find the operator, right? So we have a find feature function, remember, which takes in a game world, which is rec world, and then it takes in the current row variable and current column variable that will store the location of the thing we're trying to find. So this will be current row, current column. And then find feature, which feature we're trying to find. We're trying to find an operator. So operator. I think I need to change the find feature function. Remember, we have an enum for this. If I go to find feature function, right? Let's go to it. Yeah, there's the function. Remember, we have an operate. We have a enum for representing our features, right? So let me go back here. You see, this is our enum. Yeah, my bad. It shouldn't be called symbol. Let's call it feature. It's a game feature or something. Yeah, just maintain the same wording, right? So yeah, so that means this one here, the type would be of type feature. And then I need to change it inside the header file too. Remember the header file and the CPP file need to match. So let me check. Do I have it here? Oh no, it's not declared here because it was not meant to be public, right? Meaning it was not meant to be seen by the user. So yeah, it was only meant to be used here, so this is fine. You see, the only part I changed is here to be that type, but you see that when I build it, it runs exactly the same way. It still works. No, that's the only thing I need to change. That's the main reason about enums. They don't add that much of value, but they kind of like save you time for having to type const int and also having to initialize every constant. You don't have to initialize it because, to be honest, right, you don't actually care about what's the integer for each character, each feature, as long as there's some constant. That's all you care about. So that's why an enum is very good in that case or in that scenario. So let me go back here. So we found the feature here, and these variables have been updated since they are passed by reference. Remember, we've passed by reference. It means that the changes we've made inside the functions, they continue to exist even after you finish calling the function, which is basically at line 235. That's when we finish calling this function with the updated values of these two variables are updated. Now we now know the current row operator and the current column operator, of which I've called it current row and current call. You could maintain the same name, but then it's going to be too long. I don't want to have variables that are too long. That's my bad. What am I? Did I? Hey, oh, hey, I was. Hey, you see this thing was the weed. I thought I hadn't recorded. I haven't started recording. I'm like, hey, all this time I'm explaining, and I forgot I did started to record. So we find the feature, right? So after finding the feature here, so this is. Let me put a comment here. This is where we find the operator's location, right? In row column coordinate system, right? So after we find it, we need to have for loops. Remember our plan. We need to go through all of this, starting from that, stopping at that. So starting at row -1, so I need to have a for loop for my row, int r is equals to not 0, but current row -1. We did remember discuss this in our previous tutorial. And then is less than, it stops at exactly. That's why I'm using less than or equals to, because it should stop at exactly that location. Current call. If current row, I mean, my bad, current row +1, and then r plus plus, right? So this to be honest, this will never change. When they talk about square radius, the formula is always the same. That's why I took my time explaining it there, so that you understand when you start typing the code that I'm not just guessing this code, I am planning. So it's equals to current call -1, and then C is less than or equals to current call +1, and then C plus plus, right? And then there's my for loop, right? So I found the square radius of where the operator is currently at, right? Remember, if this is the operator, the for loop that I wrote, right, it starts from this corner, meaning that row, and it stops at exactly this row, exactly, right? But then the row might not actually exist in the game mode. Do you understand that, right? Because what if my O is here, my operator is here? That means the only available spots is the top, then top left, then the left. So there's nothing on the right, there's nothing at the bottom. So I need to tell my computer to check for that. How do I do that? I need to look at the location. I need to look at my array at the location and see if oh no, I don't have to look. Yeah, I don't have to use array. Remember, created the function code is in world, whereby it checks if the current row and current column that you're passing, they are within the bounds of the game, right? Meaning it starts at row 0 and stops at exactly rows -1. And it also start if the column should start at column 0 up to columns -1. We did discuss why that is, right? Should watch the previous recordings. So let's do those checks, right? So I'm gonna put a comment here that say check if the coordinate exists in my game mode, Right? How do we do that? Remember that function returns a boolean, which we can use in a condition for an if statement. So we're gonna pass that function inside the condition part because it returns a boolean or a type bool, which is true or false. So it's called is in world. It takes in rec world, and then the row and column you're trying to check if it's in the world, which is R and C, because RC represents the current row and current column, right? And I want to check if it exists, right? Meaning is physical, if this function should return true, because it needs to be true that the coordinate is in the world. Hence, it's called the function is called is in world. So it's gonna check. I'm gonna check if it's equals to true, meaning it is true that my coordinate is in the game world. So I haven't went outside of the game world. If now I'm in the game world, then now I can process everything that I want to process. Remember what they told you. Remember the question paper. This question paper was nice, Shem. They said it in a nice way. I just like the logic here. So so you say the region of the world within a one block radius around the operator, right, should must be visible since the operator is carrying a torch. So if you're within the one square radius, right, meaning you are here. So let's say this is the operator. If this coordinate or 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 this coordinate, meaning you're around you're around you're in the circle of the operator of where the operator is currently at. So that means it should be made visible. Remember, by default, we made it false, meaning it's not visible. So we made it invisible by default. So we need to make it visible now at that specific location, which is RC. So at that specific location. So I'm going to do that. So I'm going to say my rec world, meaning my record structure, dot array world. It's 2D array at coordinate R and C should be not array world, not array world, what is this? The other one, the Boolean one is visible because they said we should make it visible, right? So this will be equals to true. We make it visible. So basically, make the character visible, right? To make the character visible. And then yeah, we make the character visible, but then it's kind of tricky because remember you also need to make it invisible, right? So let me see. You need to make it invisible. Basically, what do I mean by that? Let me show you. So this is what it means, right? So let me put a dot here. Let me just say everything is invisible, right? Let's start by everything being invisible. Right? We can leave the star, that's fine. We just want to remove the batteries and the wires. So let's say you are currently here, right? This is the operator currently at this location. That means you have to make this part and this part and then this visible if there is a wire or a battery, right? So let's say there was a battery here. So this means it will be visible. It's the moment the player moves in this location, this becomes visible. But then the moment they move to another location, let's say they moved here, right? That means this part over here should be this. This now should now become invisible because it's not within the square radius. Now the only things that are within the square radius is these 3 points and that point and that point. So anything within here those are things that should be made visible. So now the tricky part here, right? Let me think about it. The tricky part here is we need to update. This is a tricky this is a tricky question to undo, right? That's the tricky part. But then to make it visible, this function is fine. We basically done with the function here. I think that's all you need to update. this will update and make it visible because we're using a second array code as visible. But then after updating, let's see printing, and then we try to move. Yeah, after moving, right? I think we can. You see, after moving, I'm deciding which function to put the logic for. Remember, if it moved from this location, right? Remember, this was a location whereby we had made the battery visible because there was a battery since the operator is carrying a torch. Then it moves now from there. The torch doesn't reach this part over here because this location is no longer within the square radius. So we need to change that location and make it is visible, right? To make it invisible. So how do we do that? So I think what is this going to be really annoying? I think while we should it be in the print function? No, the print should only deal with printing. I think the main important function should be the movement. After we've moved to here, we're gonna look at all the function, all the yeah. I'm thinking about actually. I just finished coming up with the formula right now. What we can do, right? After, should it be after movement? Yeah, after immediately after movement. But then this function should be called within the move operator function. But after the movement, meaning after this curly brace, that's when we start to put back everything to normal, right? That's not within the square radius. So here we should, I deleted the square bracket. Here, this is where we put, oh, come on. We should put everything to normal. That's not the square, within the square radius, right? We should put everything, yeah, everything that's not within the square radius, yeah. So that means you need a function that checks if it's within square radius. So it's checking, right? So it's gonna return a Boolean. So let me see where I can create it. They must have created here. It returns a Boolean, right? I'm gonna say is in square is in square radius, right? Meaning the location is within the square radius, right? So what do I need? I obviously need my record structure game mode because that's the record structure that stores everything. My 2D array, my size, meaning rows and columns, because we're gonna need for loops, right? So I'm going to do something here. Let me see. Oh no, you're only checking that location, so we don't actually need for loops. Yeah, we don't need for loops. Then I'm gonna pass in the row that I'm checking, and then I'm gonna pass in the column for that location that I'm trying to check if is within square radius. Then I'm gonna create a variable of type bool called is within, right? Because I'm trying to check if it's within radius. It starts by being false, right? Starts by being false. Then it's going to be tricky. Let me think about it. How do you check every single coordinate that's within the square radius? Let me think about it. If it's within the square radius. Oh, yeah. Meaning, yeah, I see. But then the square radius, this is kind of trick. Remember, we need the locations for my operator, right? In order for me to find if to check within the square radius, because it's within the square radius of my operator's location, not of the whole game mode. So I don't need the whole rows and the whole columns. I need we're gonna still pass game mode because game mode stores our array. We need the array from there. So I'm also gonna pass in two things here. So int const int I'm gonna call it operator row because that it represents my operator's row, and then const int operator call, right? which represents my operators column, right? Remember, we talked about how to go through square radius. We need that for loop. So let me go look for that for loop, which is this. But then instead of current row and current column, I've called it operator row and operator column. And then here, to be honest, I don't think I need a variable. Yeah, I'm not gonna need the variable. I'll show you how to make it, how to do a shortcut for this function. So this will be operator call, and then operator, my operators column plus one, right? And then if this location is in the world, because we need to check, because what if the location is outside the world? So we need to check if it's within the world. If it is within the world, now we need to check if that location is equals to is there's no if there's any location that's equals to this location over here. Because we're trying to check if that location is within the square radius. So here I'm gonna check if location is within square radius, right? Then I'm gonna say if my current row, which is R, is equals to my operator, no, not operator row, what am I saying? Row call, yeah, is equals to row, um, and because they need to be both true. It needs to be in that exact column in that exact row. So I'm gonna use an and then if C is equals to call. And remember, I talked about if statement that if there's one line, you can simply remove the curly braces. In this case, it's going to be one line. So if we did find the location, we can just simply return true because we found the location. But then what about when it's false? So that's where I need to, after the for loop, right? This is where when it's not within the square radius, right? Then I return false. Well, else C++ is gonna complain and say, why didn't you return false? I'm only seeing true. So remember, return does two things. To give you back that answer, which is in this case true here. It's to say return means to give back, to give you something. This function gives you true if the row and column we're trying to find exist within the square radius. And then if it's not, because remember, if this part never becomes true, the function doesn't stop. So if the function doesn't stop, then you know something went wrong. That means it was not found. So we need to actually stop it down there with a false, because it means false, we didn't find it. Because remember, trying to find if it's within square radius. And this function also returns a boolean, so we're gonna use that to our own advantage. Um, so this is update. Which function? Yeah, here. So after movement, right? After you've moved, right? So you've moved, but we still have, remember, we need to find the current location, which is the previous location of, this is going to be tricky. Let me think about it. Oh yeah, we need to, yeah, but like I said, this is going to be tricky. We actually forced to go through all the symbols in the game and check one by one. If that symbol is not within the square radius, we make it invisible. So yeah, that's what I was saying. It's a bit tricky because I need to actually go through each character. Why do I say so? Because even if this is your current position, right? How will you know this space or place was occupied? You wouldn't know. But then technically, um, yeah, technically you can cheat this, right? Technically, because remember you still have this location of the previous. Remember we have current row and current column and the destination row and destination column. So this will be the current over here. Since the operators moved to there, this would now be my destination location. But then I still have this over here, right? So I still have this over here. So I can still use that to find anything that's not within the square radius here. But then, yeah, let me not use that method because what if it removes this? Yeah, that formula becomes a problem. I actually have to go through each symbol and check one at a time. I'm gonna start here. I'm gonna ask, is this within the square radius? If the answer is no, make it invisible. Within square radius, no, make it invisible. But then, okay, this one is within, so make it visible only if there is a character. And then we go to this if there is a character because it's within the square radius. This invisible, invisible, invisible. This visible, 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 invisible. So that means that B becomes invisible, right? And then I'm not sure about the star, but then here I think the star shouldn't also be visible. So it becomes like this. Everything else becomes invisible. So that's why I'm actually gonna prefer to go through all of the locations. R is less than rows and columns. So let me see. Yeah, I need to use record. Remember we have a record structure now. So record dot rows R plus plus, and then for int C is equals to 0, C is less than record dot calls C plus plus, right? So now we need, remember we have a function that checks if a location is within the radius. So if it's within radius, so if is in square radius, right? It's within the square radius. It expects a record structure, so rec world, comma. Now it's highlighting in blue that it expects this parameter named operator row. So what is the operator's row here? It's basically destination. Remember, we've moved. Remember, like what we were talking about movement. We have current location and destination, meaning where it has moved to. To be honest, the destination variable actually stores the current because that's actually where it's currently at. But current also we will also it represents the previous. We can say that current variable represents the previous. Destination represents the current location. You could call it previous row, previous call, that's fine. If you feel like current is kind of is making you get confused. But current variable, the current variable, right? Remember we have current row and current call. This actually referring to the previous location. We want the actual current location because remember we updated it, the operator, to be at location destination call, destination row. So we're gonna use those variables for checking the location of the operator. So destination call, then which location I trying to check? Every location, so RC. So I'm gonna say R comma C and check if that gives me true. I'll teach you another way to avoid having to say is equals to true. You can do it in a different way. Right, so we have this. If it is within the square radius, right? If it's within the square radius, you make it visible. To be honest, let me see. Yeah, technically, right? This is very smart. The technique that I'm about to use. Because here, right, this is where we need to update it and make it visible or invisible. So here I'm gonna say if it's within the square radius, then you update it, right? Yeah, if it's within the square radius, then you update it. But then remember, we have a function called update. So I don't have to rewrite this, all of this. I don't have to rewrite that. I just call the function called update. So let's do that. Like I know it's kind of a lot of functions mixed together, but once you understand the flow, you'll see that yeah, it's not that bad. So we update it, right? Basically make it visible. Else, if it's not within the square radius, right? Remember, if is in square radius, it returns true if it is in square radius. But so it might not be in square radius. If it's not in square radius, then what do? We make it invisible. So rec world dot is visible. Remember, we have an array for that. At that location RC is equals to false. We make it invisible. And since we are going through the rows and columns, we know that RC is a valid location. I don't have to do any statement to check if it's in world. We don't have to do that. So that means technically the update function doesn't need to be visible in main, technically. Let me see the update. Yeah, let's check something. The rest of the world that is not within 1 block square radius, exactly, must be covered by mist. Meaning, if it's not in within the square radius, it should go back to being invisible. That's what I was doing right now. If the operator moves into the same location as the main switch, the entire world must be made visible. Hey, these people are not playing around here. You see, update part, that's like the challenging part because you have to really think. The end game is just two if statements. The updating part is the challenging part. The other parts you can especially if you understand movement, you can get a lot of marks under movement. Update is like the core part, the core logic, the main part of the practical or the semester test. So they said if the moves into the same location as a switch, so that means you need to find the feature, right? We need to find the feature. So we need to find a feature if it's within the if it's within the if it's within the what is this? If we need to find the operator to check if it has moved to the main switch. Basically, it's the move function here. As you can see, it's the move function because they said if the operator moves to the same location. So that means after moving, we need to check what we've moved into, if we've moved into a switch. So now I actually have to go to the movement function. There it is here, right? So remember, I did put comments here. So we check, actually move the feature, but then we need to check if it is in world. But then this was incorrect. Remember, I need to say is equal. I need to use equals to. So I need to say is equals to true, meaning true is it is in the world. I'll show you a shortcut, another way to write that same thing to save time. So check if I'm planning to move to a location that has a battery. I can also check if I'm moving to a location that has a switch. So else if, and then I'm going to repeat this whole thing, but then instead of battery, I say switch so that I don't have to type a lot. So if I've moved into a switch, no, it's not, what is it called? I called it a star. The constant, I called it a star. Yeah, like I said, they're using two different names for one thing. Some parts they're calling it a star, some parts they're calling it switch. Basically the same thing. They said what should happen? The entire world must be made visible. So that means I need to actually do a for loop. And these people, they are not playing around to make the entire world visible. Basically, I need to do a for loop. So for int r, they said in the entire world. So I need a loop that goes through the entire world. And my rows is inside my record structure. So record dot rows r plus plus, and then go through all of the columns. C is restant record dot calls C plus plus. They said you should make it invisible. You should make it visible. So I don't have to think about it. I'm just making the entire world. So I just call my array is visible array is equals to true because they said everything in the world should be made visible. So I don't have to check if it's this, if it's that. I don't have to check. I make everything, every RC, every row column, RC coordinate. I make it visible. Basically by changing the is visible array to true. Then we're actually basically done with the update part. So since we're done with the update part, now you can go inside your main. Remember, in main, we need to have options. Remember, we have options, of which we do, right? We do. Where's this function? The display world function. Yeah. So you see, we have this option, and we did do movement and everything. So now we can proceed, right? So what I'm going to do, right? Since I can't see, I can't keep going back and forth here. I'm going to copy these two parts over here. Copy. No, not these two parts, that part. And then put it in a comment because I need to see which letters to use when I'm getting the input, right? So now I need to create a char variable that's going to store the answer. Remember, the D, UL. We said those are called chars or characters, or in other words, they are letters, but then they're also characters. They're called characters. So we use the char data type to store it. Remember, it's a character or it's one symbol. So to store exactly one symbol, use the char data type. And this will store the choice that the user enters. So I can call it choice. Let me just call it choice. Initialize it to null or nothing, right? Then we have a do while loop. Why a do while loop? Because it needs to run at least once. Remember, we talked about loops, that a do while loop is when you want to run your code at least once. Even if the user wants to exit, they need to at least be given the options to exit, even if it's only once. And then here you say choice not equals to, I'm gonna use remember we can use cstdlib, right? For functions like to upper, to lower, those functions, right? So I'm gonna use to upper, let me use to upper, semicolon. And then the initialization, remember to allocate the game world, right? To do it once. So it's here outside the while loop. It's done once. But then you're gonna continuously need to display the game mode, right? Right. So we need to continuously display the game mode. Um, then what do I need? After displaying, right? Remember, display world comes with this output right over here, meaning it waits for you to enter the choice. So we need to see in the choice. So see in, state in the choice variable to get the user's options, right? The user's choice. Then we change it to lower to uppercase. Change the choice to uppercase. Since we're updating the choice, you can store. To be honest, you can create another char variable that stores the uppercase version of the choice. But why would you do that when you can? There's already a char variable. It's called choice. You can reuse the same variable. You're allowed. So when I say choice is equals to, then I use the to upper function, which takes in a char, which is called choice, and then return the two uppercase letter or uppercase version of this symbol. But then it's part of the cstd so I need to include it here. Hash include cstd right? And then, but then remember this function, right? We did kind of talk about it. It returns, to be honest, it actually returns an integer, of which we call that the ASCII code, right? Basically, it's the integer representation of the character. Since computers, they cannot store characters, they only speak numbers. What the programmers did, right, or people, what they did is that they came up with a way to save symbols in a computer by assigning or giving each symbol a number. So what this function returns is actually the number. We don't want the number, we want the the actual symbol. So we can do what we call casting. The first way to cast, right? Let me undo this. The first way to cast is the C style casting or the C way of casting. You can put round brackets right before that function or right before that variable, and then you pass in the data type or the type you want to cast convert to. I want to convert it to a char. But then this is regarded as unsafe, right? Because it generates what we call unpredictable behavior. So since it generates unpredictable behavior, we need to wrap it around another different way of casting in C++ via the static cast, whereby you use the keyword static, followed by an underscore, followed by cast, then followed by a less than and a greater than symbol. Then between those symbols, you put in the data type that you want to cast or convert to. This the here I want to convert to a char, and then you put round brackets here, then you pass in the variable. Right? In this case, it's a uppercase version of that variable. That's why I'm gonna pass to upper, pass, and then I also pass choice because I'm gonna make it an uppercase, then cast it back to a symbol because this will return an integer. I hope that makes sense. Then now we we check which option the user entered, right? We check each option the user entered. So let's check that option. So we use the switch statement. So switch based on choice. Remember, I made it uppercase. Remember here, I've made it uppercase. So my cases will be in up. I'm gonna, no pun intended, but my cases inside of my switch statement, they're gonna have values that are written in uppercase. So characters are gonna be in uppercase. So uppercase letter U, and then break. There's quite a lot. There's U, D. Yeah, this is gonna take time, but that's fine. D. How many do I have there before I continue? It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9. I need to do this 8 more times. 3, 4, 5, 6, 7, 8, 8. It's 1, 2, 3, 4, 5, 6, right? 7, 8, 9. Hey, am I counting correct? Let me just double check here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there's 9. I think the options are 9. Let me just check again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So we have UDL. Uh, Come on, where is it deleting? D UDL. I think R UDL. Yeah. WSA QX. X, we don't actually have to include it because we're already checking it here. You see here, this part is actually redundant, useless or redundant. So let's remove the X because it will automatically exit when you enter X. So because we said while it's not equals to X. And then here you call your functions. Remember what I said in the switch statement. If you have more than one line, you put it inside curly braces. One statement. If you have more than one statement. Let me check the movements. I'm gonna need comments for this. This is really annoying. So I need to use move up. Oh yeah, move up, move down, left, right, then move up and left. Up and left, up and right, left, right, left, right. Okay, so up, down, left, right, up, down, left, right. Yeah. So let's move the player because remember when that option is entered, the game should actually move the character or move the operator. We have a function called move operator, which takes in those two things: the rec world, which is the record structure, comma, the movement, which direction. Remember, it's of type enum, meaning it's constant. So here I'm gonna say move up. So you see why it's important to have enums. You see your code, you can read it. Move operator, and I want to move up. You see, I can read the code. I don't have to have experience in coding. And then I move this one. I move down, and then I move left. What am I deleting? Move left. And then R is to move right. 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 Am I spelling it? A spelling. And then W is to move. The rest is move up and left, up and right. So it says move up and left, and then move um up and right and right, and then move down and left, and then move down and right, move down and left, and then move down and right. And then that's pretty much everything. But then remember our game mode, right? You see that it's gonna keep displaying our game mode. That means we don't delete the screen. Let me show you. So we still have something a bit incorrect. And we also haven't done deleting, right? Yeah, you see that I'm gonna move. Let's say I want to move up, so I'm gonna enter U. You see, I've moved up, right? I've entered U. But then you see that it still prints the previous game or date is here. So I need to use cin.ignore to clear my screen before I display. You see, it's right here. Before it goes to the while condition. And then remember after the while condition goes back to the top here. Before it does that, it's up to you where you put it. You can put it down here or right before here. Right before there. You can do it anywhere. So let me teach you a skill. Let me put it right before so that you see that it works. Cin.ignore the first 200 symbols until you encounter \n. Remember, ignore is to delete, right? And did you notice that it show those characters became visible? Um, this is weird. Yeah, C++ is weird. I get what's going on now, but it will be hard for you guys to understand. But I get what's going on. Actually, always put it at the bottom here. So it's the thing that you do at the last day. You should now see the screen. Do you notice something? You see that there's nothing visible around because there's nothing around. But if I move in a different direction, maybe there is something around, symbols around it. If there is, it makes them visible. You must notice something. I press enter. You see, it made it visible, right? Because and that's the only thing that's visible. It's this B. But let's say I want to move here, right? Do you see this location over here? I get it. It's moved down. No, it's moved left. Yeah, it's moved left. Yeah. So let's move left, which is L. So I'm gonna enter L. You see, there is a moved here. But then remember, this is still part of the square radius, right? So let me move here. This is move down and left, right? So move down here, and I need to move left. To be honest, it should be vice versa. Move left and down, move left and right. No, not left and down. Move left and what? Move left and up. Move left. Move left and move right and up. Yeah. So basically here, yeah, here this part's over here. You swap the left and up. You swap the right and up. You swap the down and left and the down. Yeah. You swap the right and the down. And you notice something. The moves are decreasing. So I want to move down and left. So it's A. Yeah, so yeah, something is not right here. It's actually the way we are doing this. I think I should also have the cin.clear, right? Then I use cin.ignore. So let's do that. Let's run it again. Let's move up. So yeah, let's see. Did it move up? Yeah, it moved up. I don't know why. Yeah, we're gonna fix that later. Move up again. Yeah, I think it's kind of working. Let's see, move up within the square radius. Yeah. Do you notice something? You see the W over here. I get it was in the square radius at that point, and then I moved up to here. Now this is no longer in the square radius, so nothing should be displayed there. And then you see there it is at the bottom. It's not being displayed, which is perfect. Yeah, you see now it's displaying only the ones within the square radius, which is doing exactly what it's supposed to do. But then oh my bad. No, what am I doing? Ish, my bad. My brain. I should use system CLS. What am I doing, man? It's system CLS to clear the screen. Yeah, duh, to clear the screen. So it's gonna be you to move up. You see, now it clears the screen. My bad. That the scene ignores for errors, but to clear the buffer. We're not dealing with the buffer. We're dealing with the screen. And then I move up again, and then I move up again. You see that it makes them visible if they're not within the square radius. So I know my formula works. I knew it was gonna work, but I'm just showing you that it does actually work. And then they said if you pick up a battery, it should increase by 5, right? We currently have 12 moves, so I should actually have 17 after I move up again and eat the battery. So I'm gonna move up. Yeah, there it is. Yeah, it was 17 minus the one for the move that we made to eat the battery. So it's 16, yeah. So it's calculating properly. And it ate the battery. So the battery is no longer there. To show you that it's no longer there, right? Let me move back down. And you see that in this position, it's not there. So let me move down, which is D. You see, it's no longer there. It was eaten. So we have our game. You see, our game is coming nice. And remember, system, right, is to refer to the operating system to use this command on the terminal, which is CLS. Yeah, so this basically the commands you can run on the terminal. Let me show you that this thing is doing what I'm exactly what I'm talking about. Here's the terminal. CLS. You see that clears the screen. CLS clears the screen. So you're telling C++ to do this inside C++. And this you can call the system function, right? Which you can think of as a function that refers to the operating system. And you tell you what to do. You want it to run CLS command, which clears the screen so that you don't keep reprinting the game in one after the another, which becomes untidy. You can't see if it's actually moving or if it's actually doing anything. So it's very important to have that there as you've seen. So our game is actually somewhat working. We need the game over. So let's do that. So the game ends in victory if the operator moves to the same location as the main switch. Oh, it actually ends in victory. Yeah, it actually ends in victory when you've moved because that means it's gonna reveal everything. Remember, there's a part like that. If you move into if you find the main switch, we we make everything visible. Basically, if we eat a main switch, we make everything visible. Which is true because if you're in your room and you're sitting in the dark, right, and you switch on the main switch, which is the only switch in your room, what's gonna happen? It makes everything in your room visible, right? You can see your wardrobe, you can see your bed, right? Everything becomes visible. That's basically the same thing that we are coding in a game. I know it's cool, sounds nice, but yeah, that's exactly what we're doing. And you see that it does exactly that. Yeah, C++ is interesting, Shem. Once you mastered everything, you understand the flow, should be good. If we've moved to a main switch, remember move player. We need to go to that function move player. Remember the part where we checked if we moved into a main switch? It's somewhere here. Yeah, so here. We've now moved into a main switch, which is a star. So we make everything visible and it actually terminates the program with success, right? Meaning that you've won the game. So what can we do to tell? How can you tell the user that they've won the game? We could technically, right? We could do this. We can create a variable called is won. That's a very good idea. Our game mode, right? Inside our game mode reconstruction, let's just create that variable. Let's say we have a variable called is won, meaning you've won the game. It can either be true or false. By false, meaning you've lost, right? So I'm gonna say bool. Um, let's say bool is won, right? Let me see. Should I use it in that way? No, let me also have is lost. Yeah, let me also have is lost. Yeah, if I'm thinking about it. If I say yeah, if I do it that way, yeah, no, I'm thinking about it's not gonna work. So we're gonna initialize both of them to false, meaning no, you haven't lost, and you neither haven't won. You haven't lost, you also haven't won. So let me go back to the top here when we're initializing things here. Now we have a new variable. So dot is won. Initialize that to false because you haven't won anything. And then record dot is lost is equals to false because you haven't lost, right? You can't start by the game by losing and also start the game by winning. So we initialize it to false. Then we can say that once you've moved to the star, because that's what they've said, and then here you're gonna have the player has won the game. So how do we tell C++ that the player has won the game? I simply change the variable is 1 to true. Is 1 to true. Right? Simple as that. And then if you let me see, if you is there another part for losing? The game ends in failure if the operator touches the torch, or if the operator's torch dies, meaning there's no more moves left, or the operator steps on an exposed wire. Oh, so if the operator moves into a wire, game over, is lost. So I need to do a check for move to wire. So let me have an else if for that. So else if here, but then I haven't moved to a star, or I only moved to a wire. If I've moved to the wire, the game is lost, right? So dot is lost is equals to true, meaning true, it is true you've lost. Game is lost if you moved into a wire. But then they said if you move into a wire, or remember there's the or there's what no more moves left. When is there no more moves left? When they're equal to 0. And we're using or, so I'm gonna use these two pipes for or, because that's what it says. Or you can actually write it in the exact same order as the question. Because the question says if moves is 0, so record dot moves is equals to 0, then or record dot what dot array is equals to a wire. Basically, you move to a wire. If the move is equals to 0 or you've moved to a wire, then the game is lost. And then here I'm gonna group it so that it becomes organized. Yeah, so if your moves is equals to 0 or you've moved into a wire, then there is lost variable should be changed to true, meaning it is true you've lost. Then what we can do, right? After moving, every time after moving, we need to check, because the game can end if you moved into that something, right? Or maybe after you've moved, it's now moves is now equals to 0. We need to do something. So we need to come here and say, um, okay, it's up to you where you put it, right? It's up to you where you put it. I would suggest sometimes, most of the time, the lecturers put it down here, but I would suggest, to be honest, you put it there at the top. Why? Just put it before getting the next input right here, before C in, because sometimes the game will be actually over, so there's no need to get C in or to get an input. But this display word part, I need it to show 0 if moves is 0. If I do it down here, right, what's going to happen is that it will skip. It won't even go back to the top here, meaning I won't see updated output, right? So it's very important. You can play around when I send you the code. You can play around with it and put it down there. You see that there'll be a slight difference. So here I'm gonna check if the game is won or lost. And they can be it can be either, right? And there's or, meaning you can either win or lose. So I'm gonna say if is won, so if reqworld dot is won is equals to true, meaning it is true you've won, then should output a message. Else, because if it's not won, is won, then it means it's false, meaning you've lost. So you can have the else, or you can just use an else if it's fine. But either way should work. And then if it's lost is equals to true, then do something. So watch that something. It's simple. And a message. See out. They said if yeah, I'll just output this lines like this, then backslash n for end of line character. And then it's gonna also be at the closing part. I'll just also put here just two of them so that it makes it there's a space, so it makes it a bit beautiful, right? Then here in between, I'm gonna say see out congratulations, you've won the game, and then backslash n, and then I do the same thing for losing, but then I say unfortunately you've lost the game. And then here will be unfortunately you've lost the game. right? Yeah, I'll just put it right there, right? And then, but we are not done. Remember, if the user has won or lost, the loop needs to stop. We need to stop our game, right? How do we do that? I force it. Remember, we talked about break it and continue. Break it means leave the loop immediately. It's like a return, which leaves the function immediately. You remember, break also leaves a switch statement here. We have breaks here for switch statement. So here I'm gonna break to leave my loop. So leave the loop, meaning stop the game. Stop the game from stop the player from playing the game. Copy this break again because it also needs to stop if you've lost. Imagine your game doesn't stop even if you've won or lost. That's not a game. It needs to stop eventually, right? We're not done yet, my bad. We're not done. Remember, we need to deallocate memory, right? How do we deallocate memory? Remember, we talked about the way I was talking about the 2D array, how it works, right? You have a collection of rows, like let's say, for example, row one, row zero, row one, row two. And each row has the same number of columns. Let's say you have five columns. As you can see, it's exactly the same number of columns for each row. In a way, you can view it as like this, whereby you have an arrow there, same number of columns, same number of columns, right? Same number of columns. So let me make this as a comment. Yeah, I'm making it as a comment so that you can see why the code looks the way it looks. So in order to delete, right, we need to start by going through each row, you see, because each row has the same number of columns, right? So we need to go to each row and delete the columns, all the whole column. So I'm going to say for int r equals to 0, r is less than the number of rows, which is inside the record structure. So record.rows r plus plus, and then we need to delete. To delete, we did talk about it. If you want to delete multiple things, remember this is an array. We have a 2D array. So we're going to say delete square brackets to mean delete the whole thing. In this case, what's the square brackets? It represents this whole column. Right, it represents this whole column. Since each row has the same number of columns, we are going through each row, and then at each row, so I'm going to say record.array world. Remember, we have two arrays. Our the is visible and the array world. At the index or the row R, in a way, you can view it in this way. In a way, you can view it, think of it in this way. Remember, to index into the game, we have to specify the row and the column. In this case, we want to empty out the column. So it's like this. You don't specify anything in there. To just, which simply means or denotes to C++ that we are emptying it out. We are clearing everything. But then you don't put it there, you put it behind after immediately after the delete, which simply means delete that dimension, which is the column dimension. Now we are done with the column dimension, but our rows are still there because this is what happens. This for loop actually does this. Deletes this, deletes this, deletes this. That's what that for loop does. Then since at each year, this is a tricky thing to, yeah, and memory management is nice if you understand what's going on. Remember, we've deleted after here, right? We've deleted. Are they pointing to anything? Nope. So at each row, we need to actually tell C++ to point to nothing, which is null pointer. So dot array world dot index r is equals to null pointer after we've deleted the memory. And remember, we have two arrays. So I need to also do the same thing for my is visible array. So delete square brackets rec world dot is visible at index r. Then we make it point to nothing because it's no longer pointing to nothing. at index r is equals to null pointer, right? Then once we are done, we need to delete the rows dimension. So let's do that. So delete rows dimension. So it's delete that whole collection from record.array world, and then delete that whole dimension for my rows from my is visible array. But then they are no longer pointed to anything. You need to make it point to null pointer, right? So copy this and then say is equals to null pointer, since they're no longer pointing to anything. And then is equals to null pointer. This is visible. And then that's pretty much how you delete. We had two arrays here, so that's why it's a lot. Most of the time you're only gonna have one. So this won't be there. And then this two lines won't be there most of the time, right? In this case, we were forced to create a second array. Then once we are done, right, after the while loop, that's when we call it freeing the memory resources. So C++ is what we call memory resources, which is a space or storage. So we need to free the storage. So we need to deallocate, and then we pass in our record by reference because we want to deallocate. Then our game is done. Build and run is win. Did I do something wrong? Yeah, let me see. It is passed by reference, so it should change. How come it's not changing it? Oh, it's not as win, is one. My bad. Yeah, so no more errors. So let's build and run. And then there's our game. Then we can move up. Yeah, this is not the right thing. I can't say I've lost immediately, right? They said it's only gets lost if you what? Yeah, the last part I think is kind of wrong. Let's see. There's quite a lot of code here. It's quite annoying. Where's yeah? If moves is 0, or so it has to be one of these. It can even be both. Or I've moved into a wire, right? That's when the game should be lost. Then how can it be lost quickly like that? This thing is crazy because I said if it's lost is equals to true, and it starts as false. So how can it move to a wire? You see this thing of when there's mist, I can't see. So let me move to the right. Let's see. Yeah, something is wrong here. I don't know what the actual error is. Wait, was it even moving to the right? You see this thing of not double checking all the movements. I just assumed it was gonna work. Let me try to move up. Yeah, it does move up. Oh yeah, that means we ran into a wire. You see that is the game still continues to play. So let me show you that it's gonna end if I move to a wire. The wire is at the bottom, so I need to move down. So D to move down. Then I need to move left and down, which is here. Or basically move down and left, which is the symbol A. Since I'm gonna move into a W, which is a wire, it should say game over or I've lost the game. Enter, and then it doesn't say. So let me see. I do deallocate only after, which is fine. And then here, I think maybe the problem is here. Yeah, because it's important where you place the if statement. Let me copy this and put it there instead here, right? Before clearing the screen, check if the game is won or lost. It's either you do it after the movement, which is after the switch state statement, or before it. So let me move up, move up. There's a battery. move left, which is L, and then move left again, move down, move right, move right, move right, move right, move right, move right again, down. I think here it was a wire or something, but then it's not. Didn't I put break? I did put break here to leave once if it is won or lost. Yeah, there's some error here. We're gonna have to check it together. Yeah, but that's it for today, right? It said I'll check it a bit later, or we'll check it together maybe in tomorrow's session because it's quite a lot. I'm not perfect, also. The thing is, when you're tutoring and you're explaining, you tend to forget your logic and not pay too much attention to what you're typing. So it happens. So I'm not sure where the error is, and that's going to take us a lot of time. So that's it for today's session. We'll continue tomorrow. This is the full game, right? It's just a small error that we need to find, and then it's officially done. So our session tomorrow, we're going to start by finding that error. Once we find the error, then we start the next question paper. Hope you guys have a lovely evening.